Perhaps we are going to finish the topics on electricity. Today, we would like to move on to a totally new topic, magnetism. But who knows if we really finish the stories of electricity? Maybe yes, or maybe not. Sometimes, the development of science always brings us unexpected results or great surprises. Anyway, let's review a history of magnetism briefly. It's believed that the Chinese used a compass which employed a magnetic needle as early as 13th century BC. The early Greeks knew about magnetism as early as 800 BC. A kind of stone was found then. This kind of stone has a unique property. It could attract pieces of iron. It's called magnetite. In the 13th century, the scholars began to do experiments to study the magnetism. Here, we could summarize the important experimental results. It was found that every magnet has two poles, which we call north pole and south pole. Same poles repel each other, and opposite poles attract each other. It was proposed that the Earth itself is a large and permanent magnet. When we hang a bar magnet from its midpoint, it will rotate until one pole points to the geographic north pole of the Earth, and the other pole points to the geographic south pole of the Earth. So, the magnetic poles got their names of North Pole and South Pole from the behaviors in the presence of the magnetic field of the Earth. This also tells us that the geographic north pole of the Earth is a magnetic south pole. Similarly, the geographic south pole is a magnetic north pole. Also, the force between two poles is inversely proportional to the square of the separation between two poles. This finding is similar to the force between electric charges. However, electric charges can be isolated, such as electrons and protons, whereas a single magnetic pole has never been isolated. That is, the magnetic poles appear in pairs. When a magnet is cut in two, each piece always has a north pole and a south pole. This is totally different from the electric charges. A breakthrough was made in 1819 by a Danish physicist, Ørsted. He discovered that magnetism was related to electricity. The experiment showed that a compass needle was deflected when placing it near a wire of a current. This indicates that the magnetic field was established around an electric current and moved the magnetic needle. At this moment, we know that the magnetism was connected to the electric current. Hence, the story of electricity actually has not finished. Further connections were found by Faraday and Joseph Henry. The experimental observations showed that an electric field can be produced by changing magnetic field. Years later, Maxwell showed that the reverse is also true. A changing electric field creates a magnetic field. We have seen the connections between the electric current and the magnetic field. So, before exploring magnetism, we shall investigate the electric current first. See you next lecture.